For today's video, we're going to use Electric 6.03, so the older version of Electric, as well as WinSpice and LTSpice. We just need to click on the Electric software, then edit facet, so new facet. We're going to create inverter, create an inverter using the layout function of your electric. So before you proceed, be sure to set the following parameters. So first, technology, change current technology to MOC sub. And technology, change units. So this should be 350. Then be sure to select microns and half millimicrons. For the tools, simulation interface, spice options. So be sure to set the file format as spice3, spice level 3, then tick use parasitics and use node names. Also be sure to include the model that you're going to use for the simulation. New folder, electric, models. So for you to be able to select the file, all files must be selected. Then this will be the model. So you will notice that it is already included. Then click OK. You can now start with the layout of your transistors. In this case, you already have the transistors here, N transistor and P transistor. So get P transistor as well as N transistor. As a rule, if you are going to eventually change the size of your transistors, immediately change the size as soon as you pick your transistor. Otherwise, you might need to adjust later on the positions of your components in the said layout. So due to certain restrictions with regards to the distance between certain components. So in this case, we want to have a ratio between your PMOS and your NMOS. Let us assume a 2:1 ratio. So I'm going to assign 1.6 micro for your P transistor. And so the length will be 0.35. So that will be okay. For the NMOS, you're going to use 0.8 micro. So you notice that the transistor size adjusted as you enter the given values. So what else do you need to include in this layout? So we can connect your poly from your PMOS to your NMOS, but you will notice that if you're going to connect the active, so the green part on your PMOS to NMOS, it will never connect since they are on a different well. So for you to solve that, you need to have an interface such as the metal layer, so that you can connect the inactive to your P-active. So in this case, so you need to select this and connect it on both sides of your transistor. So you need to adjust your transistor in such a way that there will be some distance between your components. So for this one, they should overlap with one another. To verify, you can use DRC, so there are no errors. But if you will overlap this to the other well, so there will be some error. So be sure not to overlap them. But if you want to minimize the space, you can have them to be barely touching with one another. So just be sure to check. So after you have connected the inactive as well as the so P-active and inactive of the transistors, you can now connect them using the metal. So lastly, you need to have a metal one to substrate. So place one at the top and so you need to get this and place it on the bottom. Then connect the metal. So you can extend this to create a node as well as on the other side you can create the so create export. So this would be the ground and the other one would be export create export power VDD. So if you want to extend, for example, a node at the middle of this poly and this metal, so you cannot do that unless you uh, connect a node. In this case, you can have uh, poly 1 pin as well as a metal pin. So by having a metal pin and poly pin, so you can now connect to your poly and your metal. So you can have an export pin for your input. So you can use V in and V out. So you now have VDD, V in, V out, and ground. So again, before you leave your layout, be sure to check if there are any errors. So in this case, you have an error because the metal is very close to this So you need to adjust, then check again. So by adjusting, you now have zero errors. So control 9. So you can see the full layout. I've also used electric 6.03, so I can view it in three dimensional. So to do that, so in your Windows 3D display, though you can also view your layout in 3D using the latest version of Electric. Unfortunately, I wasn't able to install all the extensions needed for me to do that. So I just opted to use this uh, old version of Electric. So you can use view in three dimensions. So you can now see the layers of your layout. Okay. So you can also adjust the width so you can easily view whatever layer you want to properly see. So I just want to simulate this. So I'm going to create a schematic for the testing of this layout. So to do that, again, I'm going to create another file, which should be schematic. So inverter layout. So for me to test it, so inverter layout test. So since I'm going to use schematic, you need to change your technology to schematic analog, as well as so change units to 2000. So you'll have 1 micro. So microns have millimicrons. So you're now ready to check if your layout is working properly. So to do that, you need to first voltage source. Let us use 3.3. So if your uh, symbols are too big, you need to zoom out. You can use Control 0, your shortcut key. Then you need to have a voltmeter to monitor your input and output. You need the ground, capacitor. So select around 100 femto. Then, since we're going to use transient analysis, so you can first the voltage source. We're going to use pulse 0, 3.3, 0, 1 nano, 1 nano, uh, so 1 pico, and just use 40, 20 nano, 40 nano. On the next video lecture, it will be discussed what these values represent. So 0, 3.301 nano. So you need to delete this one P. Okay. So you now have your pulse, then the transient analysis. So that transient would be, uh, let's use 1 pico and 40 nano. So we're just going to simulate one cycle. For you to insert the layout, you need to select Edit, New Facet Instance, Inverter Lay, which is your layout, then click it on your workspace. So after you have placed your layout, be sure to click export and re-export everything. You will notice that the uh, export that you have created were now visible, such as V in, V out, ground, and VDD. So what you need to do is connect supply ground to ground. Okay, so you just need to adjust so that you'll be able to properly connect the nodes. Okay, so with this, you now have your schematic to test your layout. So since I just want to simulate if this would work properly, I will be using 1 nano, but later on the following video, you're going to use 1 pico so that you'll be getting the more accurate results. So for now, let's just use 1 nano. So tools, simulation interface, right spice deck. So I'm just going to place this on the desktop. So be sure to make the extension at the as.cir. So if I'm going to simulate this, I'm going to select WinSpice, File, Open, Inverter Layout. So this will be the result. So kindly watch the next video wherein it will show you how to measure the propagation delay for this circuit. In the next video lecture, the simulated circuit is a schematic of an inverter. So you just need to replicate this layout and use the CIR file that you have generated on your layout and follow the same procedure as shown in that video lecture. So that would be it for this video lecture. Thank you.